So good afternoon, everyone. Welcome to TEFL Webinar Series 1, organized by TEFL Program, Teaching English as a Foreign Language, Faculty of Education, Chulalongkorn University. First of all, let me introduce myself. My name is Chanukrit Tienkalaya, but everyone calls me Oat. So it is my honor to be your moderator for today. And for today's topic is getting the basics right, clarifying doubts about statistics. And today we have our speaker, Ajahn Sakol Suethanapornkul, who's going to give us a talk on this topic. Before we go any further, let me remind you just a few things. The first one, if you just got here, make sure that you use your register name so that we could conveniently monitor your class, your attendance. And also, please, if we could ask for your cooperation to stay on mute so that we try to reduce all the background noise which may interrupt the sessions. And if you have questions, you can use the questions in the chat box, or if you want to answer Ajahn during the workshop, please feel free to unmute and answer. And then last but not least, just enjoy this workshop. So for the opening speech, we would like to invite Assistant Professor Pontimon Sukawati, the Director of TEFL Program, Faculty of Education, Chulalongkorn University. And she's kindly enough to prepare a little clip to welcome you all. Thank you very much, Ajahn Pontimon, for a Director of TEFL Program, for your welcome speech. So next, let me introduce our speaker for today, Ajahn Sakol Suethanapornkul. He's received the Bachelor degree of Education from Chulalongkorn University, and he also pursued his Master degrees in Second Language Studies from University of Hawaii at Manoa, and he's also received the Fulbright Foreign Student Scholarships to pursue the master degrees there. And he just recently graduated and received his Ph.D. in linguistics with the applied linguistic concentration from Georgetown University. And today he's going to give us a talk about the statistics, which is a little foreign for us, but he's going to make it fun, interactive, and very easy to understand. So please, everyone, welcome Ajahn Sakol. Take it away, Ajahn Sakol.
ขอบคุณครับ Thank you everyone. Thank you for joining. Thank you for zooming in. I can promise you it's gonna be fun. I will try my best to make it fun. Hopefully it will be interactive. For sure, I have a couple of things to get everyone involved. But first, can I check? Can I ask everyone if you can still hear me? Can you hear me okay?
Yes.
Yeah. Okay, good. So I am going to disappear from the screen.
Okay.
I don't like to. Okay, hold on. All right. Okay. Hopefully you guys can see the slide. Okay. Let me just check. Make sure everyone sees.
Yes, we can see.
Okay. Can you see
you're
a smiley
smiling.
face? Okay.
Yes,
Good.
you're smiling.
All right. So again, thank you so very much to each, thanks to each and every one of you for zooming in. I know that statistics is a tough thing to talk about on Zoom. So let's see how it goes. Hopefully it will be, like I said, it's definitely going to be interactive, but I'm not sure if it's going to be fun. I will try and make it as fun as possible. I learned from Ode that some of you have had experience with stats. Some of you took a stats class. Some of you may never get like a first-hand experience in a stats class, right? So what I am going to do today, because we only have 3 hours for today and 3 hours for next week, I have decided to make this talk. I've decided to orient this talk around my experience learning and talking about stats. I've never taught stats. Well, I did offer a few workshops on stats, right? But I've decided to make this one about my experience, things I wish someone told me before I started learning stats and things like that, right? I'd like to share something I've learned over the years with you guys and mistakes I have made, and I have made a lot of mistakes. So there's nothing wrong. If you are thinking of taking stats class, if you're thinking about learning stats, trust me, everyone makes mistakes, and everyone makes a lot of mistakes with statistics. The most important thing though is you know what mistakes you make, own up, and correct yourself. I think that's the most important thing. I have, like I said, prepared this talk based on my experience. So we will see some of the issues that are not directly tied to stats. For the first 2 points, you will see something that's broadly about research in general. So I'm going to introduce you, hopefully gently introduce you to stats and make you buy into this idea that statistics is important and make you feel a little bit more passionate about that. And then after the first 2 points, like I said, again, which will be about research in general. After the first 2 points, I'll go deeper into stats, some of the fundamental concepts. Let me repeat again, some of the fundamental concepts. Because we only have 6 hours, I am not, just to set your expectation right, I am not gonna tell you what to do with stats. I'm not gonna tell you, you need to run this test, you have to follow step 1, step 2, step 3, step 4. That is not what I'm about. That is not what I'm gonna do. That will need 60 something hours, right? So hopefully just get the basics right, just get the fundamental concepts in place. And when you want to start learning stats, on Coursera, on some other websites, or any other places you'll like to look up, hopefully you'll have some solid ground to build on. Okay. On more heavy parts, again, some heavy parts will be toward the end of this week and for next week. One last thing before I start, I want to tell everyone, this is very important. Take this webinar as a supplement, as if when we talk about eating healthy food, right? We talk about eating different kinds of fruits and vegetables and things like that. And some of you may take vitamin supplements because you feel that, you know, vegetables, you don't get enough vegetables, you don't get enough fruits, right? And some of you take vitamin supplements. So take this lecture as a vitamin supplement. Think of this lecture as a vitamin supplement. It's not the main thing. There are still other things you need to acquire. There are still other things you need to learn. But like I said, take this one as a vitamin supplement. Hopefully it will help you, boost your immune system. Okay. Cool. All right, so let me start. I have prepared an R code. So in my presentation, in this presentation, I've used R for statistical analysis. If you know a little bit about R, if you're interested about R, you can go to my GitHub page. If you have the PDF, the link should work. You can go then look up on some R codes. They are not like the most beautiful R code you will find, but just so you know, you can use that and run that to see the same example that you will see in this presentation. So I have organized the talk based on a few issues that people have with statistics. Like I said, the first 2 points will be general. The first 2 points will be about research in general and how statistics is tied into that. Some of the common elements that people have when it comes to statistics, you might reject stats, you might put up stats. I'll try and convince you that, you know, stats is important, and maybe you should think about stats as soon as you think about your research. And then we'll talk about some misconceptions, and I will devote that part to p-values. This is something that you hear all the time in scientific literature. This is something you hear all the time in the general public, right? You hear something about something being significant, something being significantly different, things like that. What does it actually mean, right? So I will devote this part mostly to p-value. But in order to talk about p-value, we need to talk about statistical inference, and we need to talk a little bit about sampling distribution. If some of these terms are so foreign to you, don't worry. I will try and explain them. Okay, I will go through each of these concepts, and hopefully, you know, it will they will become clear at the end of the talk. And hopefully the fourth part, which is this one. Hopefully we get to talk about this next week. This is something I want to present about. This is something that I hope to encourage everyone to look into. When we talk about stats, when we talk about statistical tests, sometimes you hear words like t-test, ANOVA, and things like that. I will try and clarify, give you some basic ideas of what these things are about and how we can move on, how we can use the information we have to help us learn some more complex statistical models, things like that. Okay. Now let me introduce myself a little bit more formally. I am interested in, like Owen said, I just graduated officially 3 weeks ago from Georgetown University. And if you don't know Georgetown, it's in Washington, DC. And I graduated 3 weeks ago with a PhD in linguistics, applied linguistics concentration. It took me about 6 years in total. If any of you is thinking about doing a PhD, I would say don't do that. It's a waste of your time. But if you are really passionate about pursuing a PhD, we can talk about that. part of my research, what I am interested in is the statistical learning. And this, let me clarify this a little bit. This one doesn't have anything to do with how we learn or how we teach statistics. Statistical learning is a research program, and it deals with how human beings pick up and use statistical information in the sensory input, language included. You know, how human beings pick up and use statistical regularities, distributional information that is in a language, to learn a language. If you are confused about statistical information in a language, a very good example is collocation. The word strong T, right? For example, that's a very good collocation. Strong T, close friends, and things like that. We can think of collocations as some kind of systematic patterns. One word predicts another word and things like that. Right? So you can express the idea of systematic relationships with some kind of statistics, and statistical learning research gets people to learn, and usually an artificial language, a miniature language, a language that's made up to contain certain kinds of properties, and see if people can learn a language within a short amount of time. A language that has systematic patterns versus a language that doesn't have any systematic patterns, things like that. So that's my interest. My dissertation focused on how systematic patterns that underlined tense and aspect in English and Thai, how people use that information to learn a miniature language. That dissertation was an okay one. I wish well, it's okay. It's not perfect. I could have made a better kind of research, but it is what it is, and that's my research interest. I am also interested in statistics in general, and I use Bayesian statistics. There are two kinds of statistics. One kind of approach is called classical frequentist statistics, and we will talk about that in our talk. The other kind is called Bayesian statistics, so I use that in my dissertation. And if you are thinking about learning stats, let me tell you this. It took me about 3 years with a lot of false starts to get some basic understanding of Bayesian stats. So if you are thinking about learning stats, one thing you have to know is that there will be a lot of false starts, but don't despair. You will make a lot of mistakes, like I said. You'll have a lot of false starts, and you will have a lot of things you don't understand. But if you keep at it, if you keep pushing, I can guarantee you that everyone can learn, because statistics is such a subject that, you know, everyone uses it. So you can find a lot of information about statistics on the internet, ranging from the most basics to the most advanced. And because everyone uses it, you see a lot of people helping each other. So if you are thinking about doing this for real, use this as a supplement, right? And build on that. Build on from this one. Okay. I have talked too much. One last thing before I start. I have this tendency of, you know, as I speak, I have a tendency of shouting. If I scream into a microphone, right? If you somehow feel that I scream into a microphone, let me know. Tell me. Don't scream. Stop. Right? I have this tendency of being too overzealous about things. So let me know if I start screaming into if it's as if, you know, I am screaming into your face. Just let me know. Okay. I've said too much. It is time for some activity, and I like to start with this activity. I've coined this one symptoms of statistical disorder. statistic disorder. There is no such thing as statistic disorder, just so you know. But I've coined this one up. And I like to ask each and every one of you to jot down, to answer each of these things. And look at each of these symptoms and answer if you have it or doesn't have it, okay? Find a piece of paper, write down yes or no. Let's start with the first symptom of statistic disorder. When you hear someone talk about stats, when you know that you're going to take a stats class, for example, you become demotivated or stressed. Yes or no? Write it down on a piece of paper, or make a mental note of that. Okay. The second symptoms of this disorder, you feel some discomfort. You feel that you are having a chest pain when you have to think about t-test or ANOVA. Okay, yes or no? I'll ask you in the end, okay? Write down your answer. Number 3, keep telling yourself, I don't have time for this. You can add some expletive after this. Right? Some people say, I don't have time for this bleep. Okay, yes or no? I don't have time for stats. The fourth symptoms. Always look to hire people to run statistic tests for you. Always look around. Can anyone run a test for me? I'm going to pay you. Yes or no? And the last one. Believe that all is needed is just a bunch of p-values. Just give me the p-values and then I can graduate. Okay, I have these 5 symptoms of statistics disorder. Now, you can type up your answer. Who has got all the 5? Anyone has all 5? Okay, 3 yes, 2 no's. Three yes, 2 no. Oh, 2 yes, 3 no's. 4 no's. 1 both yes and no. Okay, depends. 2 yes. Okay, I will count it as 3 yes and 2 no's. Okay, it seems about right. We have half, right? 3 yes, usually 3 yes, 2 no's, or somewhere in between. I'll say 2.5 yes and 2.5 no's. Which one of these is super true for you guys? Which one of these is definitely right? This is 100% true. Anyone wants to share? Number 1, become demotivated or stressed. Okay, that makes sense. That makes perfect sense.
Yes. Yeah, I answer number 1, yes. Become demotivated or stressed.
Okay, anyone else? Anyone wants to say anything about one of these symptoms? Which one causes you the most painful experience? Okay, good. All right, number 3. Okay, I don't have time for this. Yes. When I prepared this slide for the first time, I actually had some expletive there, and I decided to bleep it out because I know that it's not appropriate. But I guess this is what everyone has in mind, right? I don't want to deal with stats. Like I said again, now let me be a little bit more serious. I'm going to present some of the fundamental concepts. If you feel that you can't follow, if you have trouble following, raise your hand, tell me to stop, tell me to slow down, things like that, right? I want to give you the best foundation I can, and I want to present you some of the fundamental concepts so that when you start this journey, when you begin this journey, you know what you have to do, right? Because a lot of times statistics class is a bunch of, when you take statistics, it's as if you have, it's like memorizing a cookbook. You have to remember these 5 steps, and these 5 steps don't make any sense to you. There are reasons, there are stories behind these 5 steps, for example, but they've never been explained to you why you have to do this, why you have to do that, things like that, right? So I decided to take a different approach. And of course, because we don't have 60 hours, right? So I decided to do something slightly different. Let me know if I succeed. All right, let me know if I succeed. But I think statistics should be about stories. And it is really difficult to teach statistics with stories, with ideas. Try to, get people to understand the fundamental concepts through some visualizations. Let me know if I succeed. If I do succeed, that means this kind of story works. If I don't, just tell me, okay? But in a polite way, please. Okay. All right, I've said this, so I'll move on. Why do we have to talk about stats? I think we have to start with this fundamental idea about research in general. Of course, if you are a qualitative person, stats may not be for you. And I take that, I totally understand that. But if you happen to choose to do some kind of quantitative studies and something that involves stats, I think some basic understanding or some level of statistical expertise can help you a lot, can help you improve your research. And if each and every one of us can make our research a little bit better, hopefully, we can contribute to the society a little bit more. Of course, we talk about research and how it is important for societal development, for country development, things like that. And some people say, wait, no one really cares about research, right? People in the administration, people who are in charge of a department, people who are in charge of a school, doesn't really, they don't really care about that. They don't really care about research. Granted, that's true, right? But for us, for each and every one of us, if we are on this path, if we say, okay, I'm going to do a master's, I want to do some research, and I think I'll have to use some stats. If this is the path you are on, I think having some level of expertise will go a long way toward improving your research. And hopefully, when we can improve our research, when we can improve our statistical understanding, we can ask a more sophisticated research question. If we can ask a little bit more sophisticated research question, maybe our research will be more sophisticated. Our research may be able to answer some of the most pressing questions that Thailand needs. So maybe you might think I am conflating issues. Granted, that may be true, but the way I see it is, if we know a little bit more about stats, And if we can find a way to weave stats into our research, perhaps we can improve our quality. Perhaps we can improve the quality of our research. And if our research is slightly better, maybe our country can be in a better position, perhaps, right? So that's a broader perspective that I take about stats and about research in general. Okay, so let's begin with the first point. And this first point is about research in general and how statistics is tied into that, right? The first issue that most people often have when it comes to stats is the idea that, you know, I don't have anything to do with stats. I don't need stats, and statistical analysis isn't for me. I want to encourage everyone to think of stats as a tool, stats as part of data analysis. And whether you are a qualitative or quantitative person, statistics can give you some valuable information about the path of data. Now, when we talk about data analysis, you know, broadly speaking, there are many kinds of data analysis. And when we think of stats, it's just, you know, usually these two. But like I said, data analysis is broader than statistics. And if you consider statistics as part of this, there are other things you can do that involves some basic understanding of stats. You don't need a lot of heavy stuff to deal with some of these things, right? If you see stats as a tool that helps you do something else, right? Your perception of stats will change. You'll be like, wait, I can do a few other things, right? I don't have to just run t-tests and over and things like that. One of the things I'd like to highlight is this one, exploratory data analysis. I would argue that you only need to know about explanatory and outcome variables to be able to do some explanatory analysis, right? Because this one deals with relationships between variables. Before we take a look at some of the examples, let me clarify one thing, right? You probably hear two kinds of variable. One is called, pardon my handwriting, explanatory variable and outcome or response variable. So I'll use these two terms. Explanatory, sometimes you might hear independent, and this one is dependent. I am going to stick with explanatory and outcome variables, right? So again, broadly speaking, there are two kinds of variables. One is an outcome, things you observe, vocabulary scores, TOEFL scores, things that you are interested in measuring, right? I would define these two things later on, but for now, just so you know, explanatory variables are things that you think, predicts, influences, or affects outcome variable, okay? So again, broadly speaking, two kinds, explanatory and outcome or response variable. I would say again that you will probably need some understanding of outcome and explanatory variables to be able to do explanatory analysis, right? You don't need fancy stats for this because explanatory analysis is all about exploring relationships between two kinds of variables. And you can use some kind of visualizations to help you understand some relationship. Right? And if you can do this one, if you have some appreciation of this, maybe it will help you go do descriptive or inferential stats, inferential analysis. Okay, so let me start with some exercise. There is no right or wrong answer, okay, for this exercise, but I want to get you to think about the relationships in general. Okay, I have this exercise which comes from the data I collected before the lockdown in March. So I have a small portable air detector from one of those Chinese brands. You might see them, it's very small in white. And this air detector records PM2.5 concentrations. And some of you may know PM2.5 stands for particulate matters, right? And they are tiny particles that float in the air. PM2.5, the higher the levels, the adverse effect it has on our health and our mental well-being, things like that. So I have this portable air detector and I record, everywhere I go, I try to, switch it on, record the level of PM2.5. And I thought to myself, wait, maybe I could do something with this just for fun. So I decided to collect my own personal data from January to March, a few days before the lockdown. And after that, I couldn't leave home. So I wasn't able to collect more data. So I have PM2.5 concentration levels in various parts of Bangkok, right? And I am going to show you 3 charts, 3 figures. You will see 3 figures. I want you to consider if there's any relationship between PM concentrations and the other variable you see on the x-axis, right? This is the y-axis and this is the x-axis. Consider if there's any relationship between PM concentrations and variables. If you think there is one, what kind of relationship do you see? Okay, so if you scroll down, if you have the PDF with you, you can scroll down and see the 3 figures. I'm not going to tell you anything just yet. I'll let you figure out for a few minutes. See if you can see some relationships. Like I said, there is no right or wrong answer for this one. Some of them I couldn't see myself. All right. So this is the first figure, PM concentration on the y-axis. And this is date on the x-axis. Okay. This is the second figure. The same PM concentration and date. This time you see something slightly different in the figure. And the last one, PM concentration and wind speed. How fast does the wind blow, right? Okay, I will give you about 5 minutes. You can talk to your friends. You can talk to anyone you want through a chat, okay? Or you can even, turn on the mic, scream into your microphone. I'll give you about 5 minutes. Try to figure out things. So about 3 more minutes.
Sorry, usually we can do the break room so everyone can, be in the small groups in the separate break room and then they can just talk. But I don't have that function with me.
That's
Sorry.
okay. That's okay, Club. I think you can try your hands on this, right? 5 minutes is not enough anyway, right? But pick
Yeah.
on one of the figures and try to come up with some ideas. We have about 2 more minutes. Try your best. If they look challenging, it's because they are challenging. Okay. I will tell everyone what that is. Minus, right? You see negative values for wind speed. I will go through that, but for now, um, I'll leave it. I'll leave you guys confused. Okay, everyone, did you have fun? Okay, let's start with the first figure. Let's start with the first one. This is the date from January until March, right? And this is the concentration level, right? How much do we have PM 2.5D here? Something like that, right? You may have noticed that I've color coded this. So each dot represents the level of PM concentration on the day, right? On the day I recorded it. And I color coded I split the data into morning, afternoon, and evening, right? So you see three colors, blue for morning and sort of pink, orange for afternoon and green for evening. Anyone wants to take a stab? Anyone wants to try and say, I think I saw this relationship in the data? Does anyone want to try say something about this one? Can you discern any pattern in the data?
Everyone seems quiet, or either they try to answer or they try to type right now.
Okay, time of the day and PM concentration relationship. Not much PM concentrations in the afternoon in March. Ooh, interesting. Okay, let me try. Let's see. Okay, this is March. Let me mix stuff up. Not much PM in the afternoon. Afternoon is orange. Here, 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 here. Huh. Seems like a valid point, right? Seems like a valid point. But one of you also said, oh, I mean
In
evening.
evening.
Okay. Okay. Oh, good point. By the way, speaking of that, let me just make this a little bit clearer. Which of these month has had the highest level of concentration?
February.
Maybe, right? Maybe February.
Maybe
Somewhere around there, right? You see some spikes in here, right? Over 100. Okay, seems like a good point. So again, explanatory analysis. This is not testing anything, right? This is about you knowing some having some basic understandings of variable and try to figure out the relationships. You know what? This should be the first thing you do with any statistics class. This should be the thing you learn first in any statistics class, trying to understand some relationships. Because, you know, if you know what the relationship is, if you know what an outcome variable is, what an explanatory variable is, it will make your life much, much easier. Usually when we talk about stats, the first thing we talk about is some ways to calculate means and standard deviation, right? And when you learn that, the first thing in the class, you were like, okay, no, I'm not going to take this class anymore. I'm not interested in that. So this one, like I said, again, explanatory analysis, right? Explanatory data analysis. It's about visualization. It's about finding the relationships. And you just need some basic understanding of stats. This is the skills everyone should improve on. This is the skill everyone should acquire because it is going to be very, very useful. Okay. I hope I convinced you to love stats, you know, by trying to get you to see some graphs and charts. How about the second one? This time you may have noticed that I split things into some sort of areas, right? I came up with my own way of districting. Bang Khae, Silom, and some business area. I made that up. And Thonburi. Okay. Anyone sees any relationship? Business, what area is it? Like Silom? No, not Silom. Sukhumvit. What else? Sukhumvit, Param 9, and Samyan. Yes, I think that's what I had. Silom is, you know, Silom, right? Silom is zero. Saladeng, around BTS Saladeng. So again, business is, I think business encompasses Sukhumvit, Asok, yes, Sukhumvit, Asok, Param 9, Param 9. So business covers those sort of three districts. Anyone saw any relationship or any patterning of data? Bang Khae is the worst. That's quite true. But you may also notice that I have a lot of recordings in this area. because that's the district where I live. So you see a lot of recordings in Bangkok, but yes, you see a lot of you see a few spikes in Bangkok, but there's one also, right? But yes, Bangkok seems to be maybe the worst of all.
Well, interestingly, in the Serum area, I don't see any PM during the morning time. The blue one in the Serum
Because
area.
because I was commuting at that time.
I see.
Okay, in business areas, there is no or little PM concentration in the evening. Yes, because I left because I left that area for home. So that's why. Right? In an ideal world, you would have a lot more data, right? You would have a lot more data points, and you would have to control for the number, right? You have to say, wait, I need to collect some sort of numbers from this area, and I have to distribute it, right? I have to split them into morning, afternoon, evening, and things like that, right? This is basically like personal recording, so it's not like the most systematic way of recording data. But again, in general, you would have to think about how many observations do I need for each area, right? And for how much during the day, things like that, right? Okay, Bangkok seems like, and the last one, this one has the clearest relationship, and this is the kind of relationship we talk about in statistics. We always talk about this kind of relationship in statistics, but can anyone see any relationship? Before I tell you about wind speed, because one of you noted that there's negative value. Right? Anyone saw any relationship with it? I can't keep up. Lots of answers. See, this one is the most visible one. I think this one is the clearest of the three examples. When wind speed increases, the concentration goes down. When the wind speed increases, the PM decreases. Okay, higher the higher the wind, the lower the concentration. It looks to be like that, right? So you might say there is. Oh, sorry. There is a negative relationship, right? There's probably some negative relationship. And that means the higher the wind, right? The lower the PM concentration. Seems to be like that, right? Of course, it's not always perfect. There are some cases where things are slightly out of whack, right? But there seems to be that kind of relationship. Oh, sorry. A quick note about wind speed, right? If this is a bit too advanced, don't worry about it, okay? But usually when you do analysis, when you do an analysis later on, if you are thinking about using some kind of multiple regression where you want to have, I will talk about this a little bit later in this class. When you do multiple regression, when you kind of have multiple explanatory variables, and you want to find out how those variables predict your outcome variable, right? For example, your outcome variable might be PM concentration, right? Your outcome might be PM concentration, and you want to predict it from some variable, from a combination of some variable, right? Let's say one of those variable is wind speed. There are cases when wind speed is 0, right? 0 wind speed means there is no wind, right? But what would happen if you have one of the variables being height, and you want to predict height, you want to predict concentration from the height of the person. Let's say this doesn't make sense, but let's follow this example. You want to predict PM concentration from a person's height. There is no anyone on earth, right? There is no single person on earth who is 0 centimeter tall, right? And when you do this kind of analysis, you want to try and change the variable. This is a simple explanation, okay? You want to change your explanatory variable a little bit because you don't want to have 0, because it's not the real thing, right? No one is 0 centimeter tall. So you want to change the variable a little bit. What you can do is to center the variable. That means you change the scale. You change the scale of the variable. And 0, I'm not going to go into detail, okay? But when you change this variable, 0 becomes meaningful, okay? If we have time, if you want to know more about this, I'm happy to talk about this later on. But for now, when you change the variable, you want to make sure that 0 becomes meaningful. This works for some variables that 0 doesn't make sense, okay? Okay, just so you know. For this one, for the last one, there seems to be, again, let me go back to this one. There seems to be a negative relationship. And that is the stronger the wind, the lower the PM concentrations. And this relationship, this one is a negative, right? There is a negative relationship. This sort of relationship a linear kind of relationship is what we 95% of the time, or maybe 99% of the time, when we talk about stats in TESOL program, in TEFL program, in applied linguistic program, in a lot of cases, when we talk about relationships, when we talk about statistics, it's about this linear relationship. We think that there is a linear relationship between explanatory variables and outcome variable. And this example, this figure is one of those things where you can see a linear relationship between the two kinds of variables. Okay. If this, again, let me repeat, if this is a bit too much, that's okay. You are still on the right track. Don't lose hope, okay? But this kind of analysis helps you see the relationship, and you don't need any kind of mathematical knowledge to do that. So my summary of the first point, right? If you think you are a qualitative person, you don't need stats. What I hope to change your perception is this. Being able to summarize and graph data is very crucial. And even if you are not planning to use stats in your own research, having skills to interpret graphs and comprehend some kind of statistical tests can be extremely useful. Even if you're not going to use it in your own research, acquiring this skill can be extremely useful. It teaches you something, okay? All right, so let's move on to the next point. This one is still about research in general. And after this point, we'll get down to the nitty-gritty of statistical analysis. Okay. The reason I want to talk about this point because this, for most people, this is what they think about stats. Everyone hates stats. And if you have to do it, chances are you'll put off. You'll wait until the end. You'll wait until like I have the last month to finish my independent study. This is the final month. I have to finish my master thesis. And you start freaking out, and you need someone to help you with stats, right? The thing is, this is how we usually think about research in general. You start with some research idea. You have an idea, and you have research questions. And this leads to you designing an experiment. Let's say you are conducting some kind of experiment, right? Let's say you want to predict English vocabulary scores. Let's say it's your research interest. You want to learn about English vocabulary scores. And in your research, you think English vocabulary scores depend on 3 explanatory variables. The first one is the number of books your students read. The number 2, socioeconomic status, SES. The richer the family is, the more likely the student will have better vocabulary scores. That's what you think. And the final explanatory variable is the number of hours they use English in general, right? So you have research ideas. You formulate some research questions. And then you design your experiment. You say, okay, I am going to focus on vocabulary scores. I think vocabulary scores can be predicted from these 3 explanatory variables. From this, you set up hypothesis. You say, oh, I have the following hypothesis. I'm going to test this hypothesis with some kind of analysis, right? You have questions. You don't really know what you want to do, right? T-test, ANOVA, what do I really need to do? And statistics is not your strong suit. So you go ask for help, right? You find someone to run some test. And then the back and forth starts. The person says, nah, you can't run test X because your research question doesn't work with this kind of data. And you were like, what? Right? And say, no, okay, I want to run another test. And that person said, no, you can't run that test either because your data doesn't meet certain assumptions and so on and so forth. That always happens. That happens to almost everyone, right? Particularly in the TEFL program, TESOL program, applied linguistics. Because, we don't have a lot of statistical expertise, right? We can do this well. We know what to do with these things, right? And we are an expert, right? We know what to do with these things. But when it comes to this one, the frustration begins, right? You seek help, and that person says, no, you can't do it. You propose another kind of analysis, and that person says, no, you can't do that either. And what are you going to do, right? You can't throw away this. You have 1 month before your graduation, right? This is a hypothetical situation, but this happens again and again. So from now on, if to prevent this from happening, the best thing you can do is to start thinking about statistics right at this stage. When you start formulating your research ideas, when you start having some research questions, and when you know that research questions seem a good bet, that research question seems to work, when you have that, right, start thinking about statistics. at that stage, it will solve all the problems down the road. This is what happened to me. Trust me. This is from my first-hand experience. Think about statistics at this point as you think about your research idea, right? How can you go about doing that? So I have a few tips for you. The first tip is to know your outcome variable. What is your outcome variable? What do you want to study? What is the thing you are interested in learning about? In our context, outcome variable are things like vocabulary scores, TOEFL scores, right? Or some kind of self-perceived rating, motivational profiles, right? When you ask people to complete a survey and they say 7, 7, 6, 5, 3, 2, 1, something like that, right? These are outcome variables, something you are interested in studying, something that you think is caused by or depends on some other variable, right? It can also be pass or fail. If you collect data from students, right? See if they pass an English course or fail an English course, something like that. You record pass, you record fail, right? So these are your outcome variables. As you think about your outcome variable, some of the tips you can think about, some of the things you can think about. The first one, type, right? Is it discrete or continuous? If it's a discrete variable, you can enumerate, you can list all of the answers. Pass, fail is an example of a discrete variable because there are only two options, right? And you can list the two of them. True, false also, right? Discrete, you can list all of them. You can enumerate all the things in that variable. If it's continuous, such as reaction time, if you are interested in measuring someone's response, how fast a person responds to certain things, and you record reaction time in milliseconds, that's probably continuous because you can record things like 425.4, right? Or maybe even more decimal places, or 360.12, blah, blah, blah. So continuous for discrete. When you take stats class, this is what probably the first thing you have to learn, you know, the kind of variable, right? I want to add to that. And what I like to add to that is the number of observations. The number of observations per participant. For example, again, if you want to predict vocabulary scores from the number of books your students read, their socioeconomic status and things like that, right? The focus in this case is vocabulary scores. You want to predict vocabulary scores from a few other variables, right? And you collect for each participant, you collect one score. So student 1, you have like 30. Student 2, you have 25, 20. Student 3, you have 24, and down and down and down. For each person, for each student, for each participant, you record just one score, just one score, one outcome variable, right? So this is one observation per person. But if you choose to say, well, I am interested in vocabulary scores, and for me, vocabulary is composed of 5 subparts, right? If you say that, if you say, well, I am interested in vocabulary score, and vocabulary consists of 5 subparts. So for student number 1, I am going to record vocab subpart 1, and this is the score. Vocab subpart 2, and this is the score. Subpart 3, this is the score. Subpart 4, score, right? So this one student produces more than one observations, right? This guy produced more than one observation. This is what I meant with the word observation. Okay, how many per person? Okay. Cluster, we will come back to this. We will talk a little bit more about this with cluster, right? But some basic issues, the type, the kind of observation. Okay? Think about that when you design your experiments, when you think about your outcome variable. Okay. After you are done with your outcome variable, think about your explanatory variables. The first one you have to think about is how many, right? How many explanatory variables you think can predict your outcome variable, right? What are you interested in the relationship you want to pursue, in the relationship you want to find out? The number, right? The type, again, discrete or continuous. And this one, relationship. In most of the cases, like I said earlier, we think of an outcome variable, right? And we think of this outcome variable as depending on some other explanatory variable. So most of the time, it's this kind of linear relationship, right? If this one is a little bit confusing, wait for next week. I have a little bit more explanation for this, okay? I'm not gonna go into detail just yet because this is a little bit heavy and I want to make sure that everyone feels comfortable right now, okay? Level, we'll talk a little bit about this when we see example. Now, I have another exercise. This is probably the last exercise of the day and the rest will be me talking. I have 2 cases. I am going to show you 2 cases. And in each of the following cases, can you please try figure out what an outcome variable is and what explanatory variables are? And for the outcome variable and the explanatory variables, what type is it? Is it continuous or discrete? And this might be a little bit challenging, but try and then I'll tell you more a little bit about this. Is there a cluster? Is there how many observations per cluster? Things like that. Okay. So if you scroll down to the next page and the page after, you will see 2 cases. About 5 minutes again. How is everyone doing? Are you still excited? Have you lost hope? How are you feeling? Are you still doing okay? As you go through the two cases, how are you guys doing?
So far, so good. Thank you for explaining so clearly and, slowly so we can follow you.
I hope everyone is still on task.
We're working on it.
If you think you are done, or if you are tired of this, can you please raise hand? Click raise hand, just so I know that everyone is done with this exercise. Again, if you think you are done, or you don't want to try anymore, raise hand, please. Okay, looks like everyone is still on task. No one wants to give up. I'll give everyone about 2 more minutes. Okay, if you are not yet done, try and wrap it up. We'll take a look at the answers because I haven't explained. I think I haven't told you anything about like clustering and level variables, right? So I want to take this opportunity to explain a few things here. Okay, if you fell asleep, wake up. Okay, so let's take a look at these two cases, and as promised, I'll tell you more a little bit. I'll tell you more about clustering and levels of variable things like that. But before I talk about the first case, there's one thing I want to encourage everyone to do, and that is when you collect students' gender. This one doesn't have anything to do with statistics at all. It's just being more faithful. I think we've got to admit whether or not. Okay, let me start. Let me phrase this way: whether or not you are for or against gays, bisexuals, or lesbians, or LGBTQ community, right? As a researcher, let me tell you this. As a researcher, please broaden the category of gender. When you do a survey research, for example, if you ask people to rate if they are male or female, please at least have one more category for non-binary third gender. Your survey respondents, your participants, your students will pick non-binary third gender. This is not about, now let me tell you this is not about being woke. This is not about being politically correct. This is about you representing the data in a more faithful way. Like I said, I don't care if you are for or against the LGBTQ community, right? But as a researcher, please have this other category. You don't have to go through this, like you don't have to list 10 genders, right? I think there are like 10 something. You don't have to go all the way, but please have at least one other type. Some of your students, some of your respondents, and some of your participants will pick non-binary third gender. When I did my dissertation research with Juฬาstudents, about 20% pick non-binary third gender. At least, again, be faithful be representative, represent the data in a faithful way. Okay, like I said, this doesn't have anything to do with stats, but just a way to, hopefully, who knows, one day when you start reporting this, you give voice. Maybe it could be a first step, right? You give voice to certain groups that do not have the same right as male-dominating folks in our society. Okay, enough said about that. This is not for advocacy. Okay. The first case, and the second case right here. Let me start with the first one. Yes. Okay, this is our outcome variable. Okay, this is our outcome variable. Test scores. Let's say you have a very grand project. This is like your dream project. Okay, which actually is what we should do, to be honest. We should go beyond collecting survey response from 20 people, or ask your students or ask people to do surveys on Google Doc and things like that. It's time for us to go big. If you've heard the expression "go big or go home," right? Maybe it's time for us to think bigger when we do research about teaching, when we do research about language learning in Thailand, in Asia. It's time to go beyond collecting data from like 30 people and things like that. Anyway, so this is our outcome variable. Test scores from, let's say, 10,000 students in 100 schools. And in each school, you have about 100 students, right? So this rounds up to 10,000, sorry. English test scores are a continuous outcome variable, right? Usually we treat test scores as a continuous, even though you can theoretically list all of them. You can say 21, 22, 23, 24 to 100, something like that. Right? Usually in the kind of analysis we do, we treat test scores, from 1 to 30, from 1 to 50, from 1 to 100 as a continuous outcome variable, right? Okay. And these scores are clustered within schools. What does that mean? Let me give you the very first explanation. You will see some figures to depict this idea again. We have scores, right? Think about this. Let's say this is a school. This is school number 1. Let's say school 1. We have school 2. And you collect scores from 100. So you have score number 1, score number 2, score number 3, down to score 100 from this school. Right? Score 1 here, 2 here, 3 here, down to 100. So scores of these 100 people, are clustered, are nested inside a school. There is this information about schools, right? Okay, this is the first simple explanation. We will see a bit more explanation of this. And there are student level and school level variables. When you have variables, when you collect information, you happen to collect, for this case, for this example, you have information about students, right? You have information about their socioeconomic status and their use of English and things like that. And you also have information about schools, school achievement, and school accomplishment, things like that, right? So we would say that there are two levels of variables. One level is at the student level, and the other one is at the school level. And again, the student level variables are gender, right? Schools do not have gender, right? This one is clear. Gender is at student level because for each student, you collect information about their gender. For each student, you collect their information about their family's socioeconomic status, right? So we would say that these variables are at a student level. And we also have school level variables, school achievement, right? School one, let's say you have 100 schools, and let's say you have Tem Udom, you have Suethanapornkul, you have Sakol, you have Wat Duong Khe, you have Chanpadik Tharam, you have a few other schools, right? You also collect information about each of the 100 schools. You collect information about their achievement. Is it an A graded school? Is it a B graded school? Things like that, right? You also collect information about school size. Again, this is at a school level. For each school, you might say, oh, Tem Udom has 5,000 students. Satitula has 2,000 students, things like that, right? Suethanapornkul has 5,600 students, something like that. So you have information at the school level and information at student level. I want to make you think about this. You know, when you do research, I want to encourage everyone to think about this. What kind of variable is that? What level is that variable, right? Think about this when you plan your research, because when you know stuff like this, and if you can explain stuff like this, even if you can't run statistics yourself, if you can explain things like this to a person who knows statistics, they will be able to tell you right away, you have to do this, you have to do this, you have to do this. The reason I've brought this up, because this is all about communication. If you don't want to do stats, you know, you are anti-stats, you will find someone to help you. You need to get this one right. You need to know stuff like this so you can explain to other people who can help you. Okay? Now, there's reason behind me taking you through this, okay? And this is the bonus question. This one requires a mixed effects multi-level model. If you've never heard of this one before, that's okay. I'm not gonna go into details here. I'm not gonna make you stress out about this one. Case two, sorry. You collect pass-fail, right? You have pass-fail. You carried out some intervention program for 200 students in your school. Let's say you are a teacher in one school, and your students hate English and they fail English all of the time, right? Chances are, you know, a lot of them fail English, and you decide to do some intervention program. You recruit 200 students. You let them go through this intervention program. And at the end, you record as an outcome variable pass-fail, right? Do they pass their English course, or do they fail their English course? Right? So pass-fail is an outcome variable, and it is discrete, and more specifically, it's binary. If you've never heard of this one before, fine. It's part of a discrete. Again, it is discrete because you can list all of them. There are just two options, either pass or fail, right? We would treat this as a discrete. If you go learn stats, you'll probably hear a few other terms, but broadly speaking, again, discrete or continuous. there is no cluster in the data. You might be like, wait, what does that mean? I have, in the next 2 slides, I have an explanation for that. Let me go down this list of answers for now. All of the explanatory variables are at the student level, okay? And they are a number of hours they use English, I think, right? Gender, again, at student level. Enjoyment at the student level, again. You ask each one how much they enjoy the class. The number of books, you ask each student how many books they read. Right? So this is a multiple regression kind of analysis. If you have trouble understanding the bonus thing, that's okay, right? For now, we will try to understand this distinction between explanatory and outcome variables and the kind and the level of variables. Okay, now a little bit more about clustering, and how, if you happen to have this kind of data in your master's research or in your independent study, if you are thinking about doing this, right? If you are just starting out in the program, and if you are thinking about doing some kind of research. So let's start with the idea of clustering. And let's start with the second case, right? Again, you have observations from a sample from your group of participants. For each one, you might say fail, pass, 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 fail, right? So each student is associated with one outcome variable here, right? Each person is associated with one outcome variable. And you also have for each of your subjects or participants, you also have extra information, right? You have extra information, and this one pertains to explanatory variables. If you have this kind of data, this is this is the right way. Let me put it this way. This is the right way to code data. If you have this kind of data, this is the right way to code it in your Excel. In your Excel spreadsheet, in SPSS, or any other statistical program. Each row is one observation. Each row is one observation. And in this case, one observation means one person, right? So you have one person on each row. It is standard practice to have the last column be an outcome variable, right? And I happen to call it success, which means they pass or fail the course. Right? You don't have to have it in your last column. You can have it somewhere around here. That's also fine, right? But it's usually what people do when they code data in an Excel spreadsheet. Right? When you code, this is a good tip. When you code your data, have everything in one spreadsheet, right? Each column represents variables. Each column represents variable. I figure no one would teach you this in stats, and you trust me, if you've never learned how to code data in an Excel spreadsheet, you will come up with some weird way, and you'll waste about some of my friends wasted about 5 to 10 hours recoding the data. So find, yes, yes, yes. That happened to Sontaya. Sontaya is in EIM. Right? So each column stands in for a variable. Okay? Just so you know, if you can't remember anything at all after these 6 hours, remember this. Remember this. Okay. All right. You can have another spreadsheet. You can have another spreadsheet that says gender is what, right? You can have another spreadsheet, and this is your metadata. This is your metadata, right? Okay, let me make sure that you know what I just said, metadata, right? You can have another spreadsheet that says, oh, gender, 1 means female, 2 means male, 3 means this and that, right? That's fine. But the main spreadsheet should be in this form, okay? And you will see right away with this kind of formatting, you see right away that each row stands in for one person because ID changes, right? Even if you don't know how to do stats, if you code it right, you send this file to someone who knows stats, that person can figure out right away that this kind of analysis requires X or Y, right? So this is about facilitating communication, making sure that you communicate your ideas efficiently to other people. Okay, let's go back to the first case. Let's go back to the first case, the idea of nesting, clustering, right? The idea of nesting or clustering. I wanted to bring this one to your attention because this, let me tell you this is quite a bit advanced. For a lot of stats class, you will not cover this kind of analysis, but this kind of analysis is becoming the standard way of doing analysis in applied linguistics. It has been a standard way of doing analysis in psychology. It is becoming a standard approach in linguistics. In applied linguistics, hopefully in a few years, it will be the idea that your data has some nesting. And let me show you with this example. Again, you have school 1, school 2, school 3. Right? And of course, you collect scores from 100 students from this school, 100 from this school, and 100 from this school, right? So on and so forth. The idea of nesting, the idea of clustering is important in statistical analysis because, say for example, school 1 is Tiem Udom. And if some of you are abroad, you might not know Tiem Udom, right? Tiem Udom is sort of an elite school in Bangkok, right? It has one of the top performing students. Let's say second school, Suethanapornkul. Okay. Let's say the third one, the one I graduated, Watsuti. Let's say this is not a good school. Okay. You have Tiem Udom, you have Suethanapornkul, and say my former school, Watsuti, which is a temple school, right? A lot of you know what a temple school is, right? A school inside a temple. Chances are, for students from Tiem Udom and for students from Watsuti, right? These students will perform better, right? These students in this school will perform better than students in the third school, Watsuti, to begin with, right? Simply because they are better, right? Even before you start collecting data, even before you go out collect data, these students are already better, right? And if you want to find out how their English proficiency scores change depending on a few explanatory variables, you know from the outset that these students will perform better than these students. And you want to acknowledge that in your analysis. You want to say, wait, I think I need to take into account school information, right? I need to take into account the fact that students are from different kinds of school, right? I will show you a few more examples of the idea of nesting, right? But this is something that we see naturally in every kind of research we do. If you go out, collect data from students, from respondents, from people, from different walks of lives, they have different kinds of clusters. They are nested in different kind of clusters, right? And you also have, like I said earlier, you also have explanatory variables at a school level and at a student level. So if you happen to have this kind of information, if you happen to stumble on this kind of data set, you will need a different kind of analysis, and that is called a mixed effects model, or a multi-level model. Later on, I'll tell you a little bit more about, the idea of modeling. Some people think, well, modeling is so complex. No, when we do t-test, now some of you may have heard the word t-test before. T-test, ANOVA, multiple regression, mixed effects model, and things like that. They are actually the same kind of thing. It just, they have different names, but underlyingly, they are the same thing. And when we talk about statistics, we have one chapter for t-test, one chapter for ANOVA, and things like that. And at the end of the day, you feel like, I have no idea what's going on. I don't know what to do. Why do I have to remember all of this? And that's why I said, maybe there's another way to teach stats. There's probably a better narrative. And so for next week, I will talk a little bit about this. Just so you know, when you start learning stats, you will not be bogged down by terms and terminologies. Okay, so for this kind of data, if you have this data, this is how you have to code it in Excel. Let's say you might have, sorry, I forgot to have this column. You might have a school ID. Let's say school ID column. Okay. Let's just invent a new column here, okay? I forgot to do that. Okay, let's invent a new column, and we're gonna call it school ID. For this one will be one. Okay. If you have this kind of data, you know right away there is some nesting, because you see the first row, school ID, which magically appears. The ID repeats, right? The ID repeats multiple times. And then at some point, the new one starts, but then it repeats again multiple times. You also have variables like school achievement, which, despite the fact that students change, this one remains the same. Again, these are all variables, right? These are all variables. And this is the outcome variable, right? But what you see is this thing, right? It repeats, this repeats. If you code data this way, if you find out this is how you have to code data, you know right away there is some nesting in your data set. All right, okay. Again, let me repeat. If you can't remember anything after these 6 hours, please spreadsheet, Excel spreadsheet. If you can't figure out how to code your data, you can have an easier life down the road. Okay. How is everyone doing so far? So good?
Yes, Achan. So far, so good. Thank you.
Okay. So all is okay. I hope everyone is okay. All right. One last thing before I move on to the meat of today's talk. Again, the first 2 hours just to get you excited, or not so excited, but feel positive about the whole thing. And then the last hour, I'll just destroy you. Right. Okay. The idea of nesting, it doesn't have to be students inside schools. There are a lot of examples of nesting in the kind of research we do. I am not going to go into detail why we need this kind of analysis, okay? There are mathematical reasons, there are good reasons why we need this kind of analysis, why we can't just do, why can't we just do t-test, why can't we just do ANOVA, why can't we just do correlation for everything, right? There are reasons for that. But what I want to encourage everyone to do is to think about this idea of nesting, because this is quite natural with the kind of research we see in our field. And I can tell you this, a lot of research that has been published in applied linguistics, even today, a lot of studies that are out in applied linguistics, if you read articles in language learning, most of them are good, most of them are okay. You will still find some articles, I bet, in studies in second language acquisition, especially in applied linguistics, in TESOL, a lot of the papers are still using the wrong kind of analysis. This is why I want to bring this one up, just to get you acquainted with this idea. Again, students nested within school, right? But this is not the only example. You test vocabulary, and you think there are, again, like I said earlier, right? You think there are subparts of vocabulary, and you want to test each part, and you record, again, student one, right? Student one, part one, score. Part two, still student one, right? Score. Student one, part three, score. Student one, part four, score. Student one, part five, score. And then student two, part one, score. Student two, part two, score. Down and down and down. This is the idea of nesting. Vocabulary scores that you collect. These 5 parts are nested in this person. And you want to take into consideration differences between students. One student may be very good at English. The second one may not be so good at English. So if this guy is very good at English, chances are she will excel on all of the parts, right? So you want to take this information into consideration. Again, this is the idea of nesting, scores nested within person. If you are doing things with school districts, เขตพื้นที่การศึกษา right? You focus on English test achievement of 200 schools in 20 school districts. Schools are nested within districts. Right? Some districts are better than the other, things like that. Okay? You see a lot of examples of nesting almost everywhere. So, just to wrap up this part, and before I move on to the last part, and I I have an hour. I hope I can cover all of the things I have. If not, we will have to move it to next week. But anyway, the summary, bite-sized summary of this part, know your outcome and explanatory variable. And have a clear idea as to how the two kinds of variable are related. The levels of each variable, right? Any clustering and things like that. So this, again, will help you communicate your research much more effectively to someone you need to ask for help. All right? This is the reason why I've brought these 2 points up. Because again, if you don't want to do stats, if you are anti-stats, you need to find someone to help you with. You need to help that person help you. Okay, and that's the way. Well, this comes from my first-hand experience. I helped 1 or 2 people, and I got data set in ways that I can't understand. So I thought maybe I should bring this up. Anyway, all right. The meat of the talk today, and I only have 1 hour left. The meat of the talk will be about statistical analysis, the key concepts in statistical analysis. And this is the part where people break down. Hopefully not, I am just kidding. There are a lot of misconceptions, and I am not going to go, what I am not going to do, I'm not going to show you 20 misconceptions about statistical tests. I'm not going to do that. I think it is less useful to go through misconceptions one by one. I thought if you are starting out, there's a better way. And what I'm going to do is to talk about fundamental concepts and try my best to explain each concept such that you know what it means. If you don't know the math behind it, fine. I don't know it either. But I am going to try my best to explain concepts. So when you go see this in statistics textbooks, or when you take statistics class, you won't be like, oh, I have no idea what that is. Okay. But I like to start with a few common refrain that you may hear or you may use yourself. Some people would say focus on the p-value. Make sure that the p-values are significant, which is less than 0.05. The smaller the p-value, the stronger the evidence for your hypothesis, for your argument. Some people might even be outlandish, more super outlandish. They might say, I just run the t-test or whatever. Every test is the same, right? If you happen to hear things like this from anyone, right, just nod and leave the conversation. That person is not the one you should ask for help with stats. Or if someone tells you this, just smile and end the conversation, okay? Or you can tell that person to go mind their own business, because that's not the right person to help you with stats. These ideas are all wrong. I will talk about p-values. I will talk about the idea behind p-values, right? I have a lot of stories to tell you about that. But for now, I like to start with the most basic idea, the fundamental idea of statistical inference. When we take a statistics class, basic introductory stats or some advanced stats, right? Chances are the first few weeks will be about descriptive statistics, right? Let's just say descriptive statistics. The first few weeks of your class, you will learn about means and standard deviation, right? They are all good. There's nothing wrong with that. After the first few weeks, you feel okay. You've got a handle on means and standard deviation. A professor might move on to then talk about inferential statistics. Again, my handwriting is horrible. Just know that I write inferential statistics. And then in the inferential statistics, right, the professor might start with t-test. And then you might break it down into this kind of t-test, another kind of t-test. After a few weeks, you start to get lost. The professor moves on to ANOVA. And you get anxious because you don't know what the heck that is, right? And some professors might say, no, ANOVA is not enough. You have to do multiple regression, blah, 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 blah. This is probably you experience in the class. This part is fine. This part is super okay. This part is where people get lost, right? So I think there's something missing here. And I like to start from here, okay? And that is the idea of statistical inference. I like to start with what statistical inference is and what do we do? What do people do in statistical inference? I'll briefly talk about the two approaches to statistical inference. I'll touch on the two approaches. We will focus most of the time on this type, which is called frequentist or classical. Frequentist or classical approach, frequentist or classical test. Okay. Another kind is called Bayesian. If a little bit of history, Bayesian is actually older than the classical kind. It's so funny. Bayesian is older, but Bayesian is now a new thing in stats. But in terms of its ontology, Bayesian is older than frequentist classical methods. We will talk about this a lot because this is what we do, right? Unfortunately, I won't have time to talk about this, but I think this is a better way to do analysis, better way to do statistical analysis. But anyway, I'll talk about approaches to statistical inference and the things we can do with statistical inference. And statistical inference is an umbrella term. Statistical inference consists of a few things. Significant testing, the p-value thing. The p-value is a subset of statistical inference. Unfortunately, we have focused so much on significant testing. And at the end of the day, we gain nothing from it. People are confused. No one knows what significant testing is at the end of the day. And we lost track of other things we should do. So hopefully I want to try and take a stab at this from the basics, right? And let me start with the idea of statistical inference. Okay. Now, I'm not going to go through math. I know just a little bit about math and stuff. I can show you something, right? Don't ask me to prove mathematical theorems and things like that. I can one day, maybe 5 years from now, I will be able to do that. For now, I can. Okay. Now, let's start with the idea of statistical inference. It is a process. It is a process that we do to make statements about an underlying probability distribution of data. Okay, statistical inference, let me just highlight this one, is about making statement about underlying probability distribution of data. Well, the word in red seems super confusing, right? The word in red is like, what? If you have that question mark over your head right now, this is the part I will expand upon, okay? Again, let me repeat this very quickly before I expand on this. Statistical inference is about making statements about an underlying probability distribution of data. Now, if you have taken a stats class before, you might have heard this: statistical inference or inferential statistics is about using data from our sample, to make or to find out something about the population. Again, if you've taken a stats class before, this is probably what you might have heard. Statistical inference or inferential statistics is the use of data from the sample on the one hand, to learn about the population on the other, right? You might ask, well, are they the same? Are they the same thing here? They are the same. And let me tell you why they mean the same thing, but why I choose to go this way, okay? Now, remember, we are still on statistical inference, okay? When we conduct studies, when we collect data, when we get data from some kind of experimentation, from survey, from natural observations, or from using data that are published on some website, for example. What we have is the data, right? We have data from a set of samples. This is what we have, right? We have data from the sample, from our sample. Our sample may be 20 participants. Our sample might be 200 participants, 2,000 participants. The bigger, the better. You may have heard that, right? But anyway, what we have is data. We have data, right? And let's say our data are vocabulary scores. Let's say our data are vocabulary scores. This is what we have in our hand. When we conduct statistical inference, we want to know we want to find out how these scores pattern in the data, pattern in the population. How do the scores pattern in the population? What is the real scores? What is the true scores in the population, right? We do not have access to this, right? We do not have access to this. We have access to this one. We have to make inference about the population from the data we have. The first step in mathematical sense, the first step people do in statistical modeling is to say, we think these scores, the things we observe, the things we have in our hand, comes from some kind of probability distribution. This is the most fundamental idea in statistics. The data we have, we think they come from some kind of probability distribution. And this, if you go read a statistic textbook, you see this symbol. This one means is drawn from or is distributed as. So because our scores because our scores are continuous. We think our scores, the one that we actually observe, comes from a normal distribution. We think that these scores comes from a normal distribution. And this is a symbol for normal distribution, which is one kind of probability distribution. I'll have a few more examples to explain what probability and probability distribution is. Okay, but the first step in statistical inference is to say the scores I have, I think they come from some kind of distribution. And let's say, again, because it is continuous, right? We think it comes from some normal distribution. And what is a normal distribution? You may have seen this kind of graph before, right? The bell curve, normal looking kind of distribution. This is normal distribution. Now we say that the scores come from a normal distribution. We randomly sample these scores. We randomly collect these scores from this distribution. We think the population, the scores in the population have this kind of distribution. Okay. Now, how do we construct this distribution? How do we construct this distribution? Perhaps you can do it by hand, right? But mathematically, you don't want to do that, because for a lot of distribution in statistical analysis, there are population parameters, things that can describe the distribution. This is mean, this is standard deviation. If you can't remember this, that's okay. The basic idea that you have to get is this one: the scores come from some kind of distribution. And in order to describe that distribution, you need to know something about the key points, the key elements of the distribution. And this is the reason why when you take stats class, some professor would say, we use inferential statistics to use our sample data to learn about population parameters, because we want to find out about these two things. Okay, let me repeat one more time. The first step in statistical inference, we have data, right? From this data, we think the scores we have come from some kind of distribution. We may choose to say that our scores come from a normal distribution. And when we choose to do that, when we choose to say scores come from a normal distribution, in order to describe the shape, the pattern of the distribution at the population level, we need to know the elements of the distribution. For normal distribution, there are two things you need to know about. When you know these two things, you can construct a probability distribution. And these two things for a normal distribution are standard mean, the average, and standard deviation. Okay? This might be a bit heavy, but let it sink in, right? If you still have questions about this, feel free to ask it, right? Interrupt me, ask me questions, or come back to me next week. We can talk a little bit about this. Okay, so this is the first step. We have data. We think this data comes from some distribution. And in order to know the distribution, you need to know the elements, the features of the distribution. For a normal distribution, there are two things. If you know these two things, you can build a distribution. You can construct a distribution. Okay? This idea of building a distribution, constructing a distribution will come back again when we talk about testing the p-value. Because when we test for significant testing, when we test for p-value in frequent test methods, it's all about constructing a hypothetical distribution. Okay? How do we, from this data, how do we know that it's a normal distribution? From this cloud of data points, right? From this cloud of data points, how can we say that it is drawn from some kind of distribution? How can I say that? How can I say that scores that I have come from a normal distribution? There are two key concepts that rarely get talked about in statistics class, in applied settings, in applied programs. And those two concepts are random experiments and random variables. Now, so imagine flipping a coin, right? Imagine flipping a coin or taking a person's temperature, right? Nowadays, everywhere we go, before we enter a department store, before we enter a gym, right? Our temperature is taken. So imagine flipping a coin. Imagine taking a person's temperature. Before you do that, before you flip a coin, before you measure a person's temperature, you don't know what the result will be, right? You will only know the results, you will only observe the outcome after you perform the action, after you flip the coin. You know it's head, you flip the coin again, you know it's tail, right? So this kind of process is referred to as a random experiment in statistics. A random experiment in statistics is an event. You don't know for sure what the outcome will be. It doesn't have to be like an experiment we do in the kind of research in TEFL, in TESOL, right? The idea of random experiment in statistics is very simple. Any observation, any event that you don't know the actual outcome, you have to perform that. You have to perform the action. You have to go through that event to know what the outcome is. So flipping a coin, right? Coin tossing, taking a person's temperature, measuring your students' TOEFL scores, and you name it. Anything, any kind of event that you don't know what the outcome will be beforehand is a random experiment in statistics. A random experiment generates random outcomes, right? There is some randomness in the outcome. Sometimes, imagine flipping a coin again. Sometimes it's heads, sometimes it's tails. Sometimes you get a series of heads, right? You get head. Sometimes you get a series of head, right? Punctuated by a tail. And then you get another series of head again, and then tails. You don't know the outcome until you flip the coin each time, right? Okay. A random experiment generates random outcome. And a random variable is just a number. Random variable is the number you assign to each outcome in the random experiment. A random variable in statistics and you will find some similarity. You will find some similarity with the variables we've talked about previously, right? There are two kinds of random variable in statistics, discrete and continuous. And your outcome variable is, in fact, statistically speaking, your outcome variable is a random variable. Before you observe your students' test, before you ask your students to take a test, you don't really know if they will, what score they will get, right? So your outcome variable has this idea of randomness in it. Why do we have to talk about this? Why do we have to talk about random variables in statistics? Because in statistics, things that are random can be associated with a probability distribution. And once we know that our outcome variable can be associated with some kind of probability distribution, we can do a couple of things. We can do so many things with our outcome variable. Okay, for now, the basic idea is our outcome variable, because there is some randomness in our outcome variable, it is likely to be a random variable in statistics then. Later on, I made a point about characteristics of a random variable. You can Google that. And there will be some explanation of random variables in statistics, right? So I encourage everyone to Google that. But for now, let's assume that our outcome variable is a random variable. Before we talk a little bit more about that, I know some of you may have problem with probability. What actually is a probability and a probability distribution? So let's say we have we have a measure of speech error. Let's say you are interested in the number of errors your students make when they perform some kind of spoken task. You record the speech, right? Could be like it could be a narration, it could be a description task or anything. And you count the number of errors. Divide that by the total number of words you times 100 to turn it into a percentage. Let's say you have this measure and you call this measure speech error. And imagine now, to visualize probability, imagine having a container, a beaker, a bowl, a jar, an urn, or anything. Imagine having a container, and inside that container, you have a bunch of values, a bunch of numbers, right? Which represents speech error. Mm-hmm. You empty that container. You empty that container. And the scores, this error is sorted from left to right, right? From lowest to highest. And the size of the bar, oh, sorry, the width, the height or the width of sorry, I think, can anyone still hear me okay? Can you all hear me? I think
yes, yes, I can still hear you.
Okay. the height of the bar or the size of the ball. The same thing here, okay? It represents frequencies, frequency of occurrence, or credibility. Again, the height represents frequency of occurrence or credibility. The distinction here is whether you are following a frequentist or a Bayesian analysis. Doesn't really matter. The idea is, as you sort the values from left to right, lowest to highest, you see the value and the kind of frequency each value is associated with. And you put some curve on that. This is a probability distribution. It represents some value. And the instances or the credibility of each value. Right? This is the idea of probability. Okay? Now, let me move on. Ooh. I said earlier, right? I said earlier, what's the matter? Why do we have to care about random variables? Why do we have to talk about probability distribution? The idea is, if we know, and if our outcome variable meets characteristics of a random variable, we can assign a probability to it. Right? We can say it follows a normal distribution. It follows this distribution. It follows that distribution. Right? And when we say it has some kind of distribution, it has some form of probability distribution, we can make a theoretical probability distribution. And just to show you an example, let's assume, okay, if you have trouble figuring out why it is the shape, why it is in the shape it is, what this actually means, there's just one important information I want you to get, and that is, if we can plot it, if we can make a distribution like this, for example, if we can make this distribution, we can ask ourselves, from this distribution, how likely, from this distribution, how likely will we see a value, some value, under this probability distribution? Again, if we can construct the probability distribution, and the computer program will do that for us, right? So we don't really have to do it ourselves. But if we know that somehow in our analysis, there is probability distribution, when we know that there is some probability distribution, we can ask how likely we will observe a score given this distribution, right? And for this example, the probability of observing a score of 20 or greater is just something like this, okay? The reason I'm bringing this up right now, because when we go and talk about significant testing, finding the p-value, right? The idea will come back again. And that idea is the null hypothesis. Again, I will expand on this, the idea of the null hypothesis. When we test, when we find out if something is below or above 0.05, 0.05, right? When we find out if something is above or below 0.05, what we actually do is that we set up a theoretical distribution of the null hypothesis, and we ask how likely is it that we will see some value inside the null hypothesis. Again, I will expand on this because this is the point that everyone is lost all the time in statistics class. I will expand on the idea of null hypothesis. I will talk more about some kind of distribution, right? The goal of our discussion is not for you to be able to construct a theoretical distribution. What I want you to get at the end of the day, after 6 hours, is to know, in fact, what is going on, right? Just know what is going on. If you get the idea that, okay, when we test for p-value, it has to do with null hypothesis. It has to do with checking the null hypothesis to see if that value is possible, right? If you get this idea, if you know, if you can verbalize this idea, that is already great. That is already great because a lot of people got it all wrong, okay? And this misconception about the null hypothesis leads to some weird idea of saying that the effect is real, saying that the effect is true, saying that something is up, stuff like that. We will talk about this next week. And when we look at the significant testing, we will know what it's actually meant to do. And it doesn't do much. It doesn't do much at all, okay? But again, I sort of try to talk you through this because the idea of some probability distribution is important, okay? All right. I think this one can be dealt with later. So let me rephrase myself. Okay. So I said earlier, right, that statistical inference is about making statements about probability distribution of the data. Right? So in fact, when we learn about that, right, when we say scores, let me just write this one out one more time. Okay. Right. We say our scores comes from a normal distribution. And in order to know how this distribution patterns in the data, in the population, we need to know these two things. Because once we know these two things, we can describe the shape, the form, the look of the distribution. So this is why, in fact, when we do statistical inference, we use sample, the sample we have, to try to learn about population parameters. If this still confuses you, I have another example to show you. Let's say, just to make things as concrete as possible, okay? Suppose your family runs a private school. Let's say you are from a wealthy family and your family owns a school. And let's say you have 500 students. Let's say you have 500 students in your school, okay? And you notice that in the classes you teach, you notice that your students have problem discriminating minimal pairs, right? A very good example is it bear or pair? So you notice that your students have this difficulty discriminating the two minimal pairs. Every class you teach, you sort of notice this. So you want to improve your students' ability to discriminate minimal pairs. And you come up with a fancy kind of experiment. You come up with a fancy idea. You said, I am going to have a perceptual training. I'm going to have students listen to some cool things that you've developed. And you want to test this out. So you recruit 30 participants as an experimental group, and you recruit 30 participants for control. They will not listen to anything. They will just take a test, something like that. So you have this, you have devised a very cool thing. You think this is so cool. This is going to change the world, right? And after this training, at the end of this training, you have participants, 60 of them, right? Control and experimental. You have participants listen to a bunch of new sounds. So one person listens to like 10, 20 new sounds, let's say. And each time they hear the word, they have to answer by pressing a keyboard. They have to answer if it's a bear or pair, a bear or tear, and so on and so forth. Right? And you say you are going to use reaction time as your outcome variable. You are going to assess how fast the two groups answer the questions, right? Let's ignore the accuracy. Let's ignore the accuracy. Let's say everyone answers okay, right? You measure the time it takes for each person to answer the questions, right? And let's say in red is the control group. In black is the experimental group. Reaction time in milliseconds. The lower the number, the faster, right? Reaction time, the amount of time it takes, that smaller values means faster, right? Smaller values mean faster. Okay, so let's assume that this is your outcome variable, right? You have data from experimental group, you have data from your control group. This is all you have, the data you have, right? Mm-hmm. What you are interested in, right? What you are interested in is the effect of training. You want to find out the effect of training. How much faster, right? How much faster for the experimental group? That is in statistical inference. In this example, what you want to learn about, again, is the effect of training on RT, on reaction times, right? This is the same thing. This is me rehashing the same point, okay? You think there is a true effect in the population. You think there is a true effect in the population, right? But what you have access to, again, is the data, is the RTs. You have this as data, right? But you believe that there is a true effect in the population. And you think that this population, you can come up with any Greek letters, right? Doesn't matter. But of course, there are conventions But for now, I'll use discrete later. You have data, right? You have data. You think there is a true effect. What you want to find out, again, is some kind of distribution, right? You can call this a normal distribution or whatever distribution. Doesn't matter for now. You think there is a true effect, and this true effect has some distribution, has some probability distribution. And this true effect with this distribution actually gives rise to the data we have observed. Right? Our goal in statistical analysis, our goal is to use the data we have to learn about this. Okay? For the last 10 slides, I am basically repeating the same point. So if you are, again, if you are a little confused, if you are not sure, keep this PDF, don't burn it. Don't chuck it, okay? Don't burn it, don't trash it. Just keep it and, review it whenever you want, all right? But the idea is the same. What we want to do, what we have is this. We want to learn about this, right? We want to learn about something in the population. But this something in the population, we think, comes from some kind of distribution. Broadly speaking, this is what we do, right? And the math part, when you have to run this and this and that, and the program will figure things out for you, right? That's beside the point for now. When we try to use our data, right? When we try to use data to learn about some population parameter, the true effect of training, this is called point estimation. Just so you know that there's this thing. Doesn't matter if you remember it, right? But this is called point estimation. We try to estimate the true effect of something, right? And this is different from significant testing, obtaining a p-value. Right? This is different from significant testing. Unfortunately, a lot of focus is on significant testing, and we don't really talk much about this at all. Right? So this is why I'm trying to bring this up, the idea that we try to learn, right? The true effect, that's what we are actually interested in. That should be our goal of research, right? When we do research, we want to learn about the effect. We want to know how this training actually improves our students, right? We want to find, we want to quantify, we want to estimate some kind of effect, right? That should be our goal. Significant testing is a different kind of story, okay? When we talk about learning about parameters, right? Finding, estimating parameters, there's one important concept. There's one concept, and I think I can end at 4 on time. And that concept is a sampling distribution. Now, this is a quirk. Now, let me walk you through this. You don't have to remember this, okay? In frequentist analysis, parameters are fixed. It is thought to be fixed. If you don't know what that means, it's okay, right? When it is fixed, when the true effect that we are interested in at a population level, when it is thought to be fixed,
When a value is fixed, you can't give a probability distribution to it. And when you take statistics, you will hear this term, sampling distribution. Okay, you might be like, what is that? What does it have to do with the probability distribution that we've talked about, right? So let me walk you through this last concept, sampling distribution. If you have a single sample, let's say for now, let's say we focus on the experimental group, okay, the 30 participants that go through the training. Let's say we take these 30 participants out. We can calculate means, we can calculate standard deviation, right? Let's say these are the data, and let's say this is the mean, and their standard deviation of this group, the 30 participants we have, all right? The mean reaction time is about 500 milliseconds. Okay, suppose we have this following data. Let's imagine further that the true reaction time of our experimental group is 550. Let's say that this group, the true reaction time, the amount of time it takes in the population for this kind of group is 550. Let's make this up, okay? This is made up. The mean of our sample, right? The mean of our sample is 526, which is not close to the true reaction time. Okay, right now, these are what we have. Imagine, because, you know, let's suppose we have a lot of time and we have a lot of money, and we choose to repeat the exact same experiment 20 more times. Let's imagine that, you know, we don't have anything else to do. We just want to repeat the same thing. From the 500 students in our school, we sample 30, we run the experiment. We sample another 30, we run the experiment. You do this, right? 30 times in total. And you plot, you find the scores, right? You calculate the scores, you plot the scores. For each one, this is the first experiment down to the 30th experiment, right? Let's say we run this experiment time and time again. All right. And after the 30th time, you are tired of this. You try to find the you try to find the average of each sample, right? You find the average of each sample, each of the 30 samples, you find the average of that. You plot those values and calculate the grand mean of the 30 samples. And this is what you get. And the average, the grand average of the 30 samples is 553. If we have one sample, we have what 526, right? But imagine repeating the experiment again and again and again and again. Imagine repeating this 100 times. Imagine repeating this experiment 100 times, okay? Not just 30. Even we did it 30 times, we get something that is very close to the true population effect, right? But imagine doing that 100 times. What's going on? If we repeat this process 100 times, we would get 550. right? We would land on the true effect. Oh, sorry, we would land on the true reaction time of the experimental group. You might ask, what is the purpose of this experiment? What is the purpose of this thought experiment? The idea is, in the kind of analysis we do, even if we never know, again, in the frequentist analysis, in the things that we often read or hear about, we don't know what the population parameter is, right? But we can find a way through repeated sampling. And this is a thought experiment. This is a theoretical kind of experiment. This is not the actual one, right? Even though we do not know what the true parameter value is, even though if we don't know what it is, if we repeat the experiment, if we conduct an experiment indefinitely, and if we calculate information from the samples we have, and we find the grand scheme, we find the grand score of those samples, at the end of the day, using our samples, we will land on the true population parameter. Okay, I know this is a lot. Hopefully it will bring you back next time, okay? Hopefully it will convince you to come back next time, because I have something to talk about with significant testing, and a little bit about, t-test, ANOVA, and things like that. What it means when I said everything is the same, okay? Let me end by saying, if you feel tired, if you feel exhausted, it's okay. Statistics should not be a 3-hour subject. Maybe statistics should be like a 1.5-hour class. You feel discouraged, you go home, get some rest, come back again, things like that. Don't lose hope if you are serious about stats. We can do it. Okay, I think I am done for today.
All right. Thank you very much, Kap Ajahn. Thank you so much. And okay, so let me close this. All right. So I hope everyone you got to learn more about statistics and the basic that you get it right on track to your future or your upcoming research on your either master projects or the thesis. And thank you again, Ajahn Sakol, for giving your valuable time to give us some talk about this. So a few key takeaways that I've learned from you today. The first one, statistics is you should see it as a friend, not a foe. The second one, you're taking different approach by telling a story of how the statistics happen. So it's different from different classes where we start from formula and things like a number first. The third one that I learned is about start thinking about statistics at the beginning stage of your research, not wait until the end. And next is perhaps the more sophisticated statistics, the more refined and impactful of your research is. So think about your research and make it meaningful. Number 5, know your exploratory and outcome variables well and see the relationship between those two. And also code everything in Excel just to make sure.
Good point.
And then we learned about 2 key concepts of the statistical inference, the random experiment and random variable. And last but not least, the concept of probability distributions and sampling distributions. So I hope I get this right. So thank you very much, Kapajan Sakol. So, and thank you everyone once again for attending this webinar. And once again, we have another session next week. Okay, so if you have questions, feel free to stay a little longer after this closing, and then maybe, you know, he can take this question or explain it some more. But thank you again, everyone, and I'll see you next time. ขอบคุณครับ Okay, thank you very much, everyone. So you have any questions? I know it's already 4 o'clock. If not, thanks again. And if you still have questions, feel free to, you know, have a little chit chat. If Ajahn Sakol have time, do you have time or you need to go?
Like everyone is logging off.
I know.
ทุกคนเบื่อแล้วทุกคนบอกมาแล้ว
It's quite a load full of, you know, information, but it's great. It's a great session. I learned a lot. So thank you, everyone. So thank you again ครับอาจารย์ and I'll see you next week ขอบคุณมากครับอาจารย์ครับขอบคุณอีกครั้งนะครับบ๊ายบายครับสวัสดีครับอาจารย์ครับ Okay, thank you น้องอุ้ม